Master Vectorization in Python for faster ML models. In this video, you will learn how to optimize your machine learning models using vectorization techniques in Python to enhance efficiency and speed.
Have you ever wondered how top data scientists manage to process gigantic datasets in minutes? The secret lies in a technique called vectorization. In today's video, we'll explore how vectorization can revolutionize your Python code, making your machine learning models not only faster but more efficient. By replacing slow loops with vectorized operations, you'll tap into the full power of Python's libraries, drastically reducing execution time and improving performance. Stick around as we delve into the power of vectorization and how to apply it in real-world scenarios.
The first step to mastering vectorization is understanding the difference between traditional loops and vectorized operations. In Python, loops are often slow due to the interpreted nature of the language. Each iteration in a loop requires overhead, making it inefficient for large-scale data processing. Vectorization, on the other hand, takes advantage of Python's powerful libraries like NumPy and Pandas, which are implemented in C and optimized for performance. By converting loop-based operations into vectorized ones, you can significantly cut down on execution time. Imagine transforming complex loops into concise, readable, and lightning-fast code. This is the essence of vectorization, simplifying complexity while boosting performance. NumPy is the backbone of vectorization in Python. It's designed to handle large datasets through its support for multidimensional arrays and matrices. By using NumPy, you can perform element-wise operations on arrays without writing explicit loops, which makes your code not only faster but also cleaner and more maintainable. For instance, adding two arrays element-wise or computing the dot product can be done in a single line. This is where the true power of NumPy shines, as it allows you to perform complex mathematical operations efficiently. Join us as we explore how to leverage NumPy's capabilities to optimize your machine learning models.
While NumPy is perfect for array-based operations, Pandas extends these capabilities to data manipulation and analysis. Pandas is built on top of NumPy and provides high-level data structures such as data frames that make it easy to handle and analyze data. By using Pandas, you can perform vectorized operations on entire datasets with ease. Whether you're cleaning data, aggregating results, or transforming datasets, Pandas' vectorization capabilities enable you to execute these tasks efficiently. In this segment, we'll demonstrate how you can use Pandas to streamline your data processing workflow and achieve faster results.
In machine learning, the efficiency of your model training process can make or break your project's success. Vectorization plays a crucial role in optimizing this process by reducing the time it takes to iterate over large datasets. By leveraging vectorized operations, you can significantly accelerate the training phase, allowing your models to learn from data more quickly. This is particularly important in real-time data analysis and large-scale machine learning tasks. In this section, we'll explore practical examples of how vectorization can be applied to model training, ensuring your algorithms run at peak performance. Let's put theory into practice with a hands-on example of vectorizing a machine learning algorithm. We'll start with a simple loop-based implementation and gradually transform it into a fully vectorized version. Using a real-world dataset, we'll demonstrate each step of the process, highlighting the performance improvements achieved with vectorization. By the end of this segment, you'll not only understand the mechanics of vectorization but also be equipped with practical skills to apply these techniques to your own projects. This is your opportunity to see vectorization in action and learn how it can revolutionize your coding approach. While vectorization offers numerous benefits, it also comes with its own set of challenges. Common pitfalls include increased memory consumption, limitations in certain operations, and potential sacrifices in code readability. It's crucial to understand these pitfalls and how to mitigate them. For instance, while vectorized operations can simplify code, they might also make it less readable if not implemented carefully. Additionally, some operations may not be easily vectorized, requiring alternative approaches. In this block, we'll discuss these common pitfalls and provide strategies to avoid them, ensuring your vectorized code is both efficient and robust.
As technology evolves, so do the techniques for vectorization. Future trends point towards advancements in hardware acceleration, such as GPUs and TPUs, which offer unparalleled performance boosts for vectorized operations. Additionally, new libraries and tools are emerging, making vectorization more accessible and efficient. Integration with machine learning frameworks continues to improve, enabling seamless application of vectorization in complex models. As big data analytics grows in importance, the demand for efficient data processing techniques like vectorization will only increase. Join us as we look ahead to the future of vectorization and the exciting developments on the horizon.
As we wrap up, remember that mastering vectorization is a vital skill for any data scientist. It not only enhances the speed and efficiency of your code but also transforms your entire approach to machine learning. By embracing vectorization, you'll be better equipped to handle large datasets and optimize your models for superior performance. Thank you for joining us in this deep dive into vectorization techniques. If you found this video helpful, please like, share, and comment below. Let us know what you'd like to learn next, and don't forget to subscribe for more insights into the world of machine learning.